Okay, so this is the third meeting of IPv6 Council. Thanks a lot of guys to be here again to follow. Our community. So I think that the community is growing, and so day by day, and so we are obtaining a good result. So I think that me and Aldo and also the other guys for IPv6 Council prepared an agenda in the same, so starting from the last topics that we faced in the February meeting. So you remember that I just made a little introduction about Sky Italy and how Sky Italy changed the paradigm, deploying the greenfield network, IPv6 greenfield network, and arranging some future, some to deliver IPv4 as MAPT. And now we have reached Patterson. He's technical manager. I work with him. He's very smart and very good guy. It's a leader, this guy, and he will speak about the Sky IPv6 deployment in Italy, and also will face a MAPT solution that has we deployed in Italy. After the speech of Richard, Pietro will illustrate the advantages about IPv6 to support the new challenging about the artificial intelligence and how IPv6 can help the develop of this new technology in Italy. Then a quick topic with a quick discuss with Giuseppe that we speak about IETF 112. So and also all the specific so the discussion at the point, the open point at the state of where we are about this topic. And then I will do a little closure after all the discussion. Also, if for all the people that are able to do are available, we can also we can do some brainstorming, speaking about the topic that we faced. Okay, so just with a little. So how you please stay mute. In case of any question, so chat the question in Zoom, and so it's I can refer the question to Richard or the other speakers. Okay, let's get started.
I will stop share then. So probably Richard, if you want to start, the floor is yours.
Thank you. Let me share PowerPoint, and looks like I have permissions, which is good. Okay, thank you, Giovanni. My name is Richard Patterson, and I'm a technical manager at Sky, where I look after the design for our subscriber termination and metro access networks across the Sky group. And so a bit of a overview of both of our V6 deployments. The Sky UK broadband network has been around for a while, and it has been dual SAC since 2016. We don't use any network side disablements, so that is V6 on for all of our customers and new provides. It was a brownfield deployment. We turned it on an existing customer base, so that had its own challenges. And as mentioned, it's dual stack where we use /56 size PDs. The UK has a mix of both IPOE, which is native DHCP, as well as PPPoE, the more traditional sense. That traditional PPPoE deployment is a dwindling number that's going down. In 2019, we launched a over-the-top voice service, and this was making use of IPv6 between the ATA or the CPE and the Access SBC. Fast forward a couple of years, and we built and launched the Greenfield broadband network in Italy. As I say, it was Greenfield. It was built everything from scratch, and we came into it with an idea of so IPv6 first, and all of the getting rid of any perhaps legacy technical debt or problems that we experienced with a brownfield deployment in the UK. So we got to deploy things that we wanted to deploy in a way that we wanted to deploy it. I mentioned V6 only recursive DNS, so we don't actually we don't have v4 bits on our recursive DNS platform. So the Sky Hubs will be using V6 transport to query for v4 A records as well as v6 quad A records. Like in the UK, we're delivering voice over IPv6, but unlike in the UK, we opted to go for a larger /48 size prefix delegation. This is for no other sort of major reason, just then it seems to be the way that the industry is going towards having the larger /48 size PDs. We don't really make use of many additional /64s internal to the network, but we do have a couple of small use cases where we are using one or two extra ones for other services other than just the standard LAN network. Since sort of the end of last year, by December, we have gotten into we've migrated over 99% of our customer base onto MAP-T, so delivering IPv4 as a service using V6. We haven't quite yet turned off the DHCP-v4 servers yet, but that should be relatively imminent. This was our projected forecast of the migrations from dual stack onto IPv4 as a service, or MAP-T. The light blue and dark blue are the forecasts of our two major product types, and the red and yellow are the actual migrations. So you can see that we did have to pause and delay for a couple of times for a variety of reasons, but then the migrations ramped up, and we consider it complete. We are ahead of where we expected to be, and it's on by default now. I say it's on by default for all new customers. We still have them connecting as dual stack initially, and then we'll do an enablement of MAP-T following that. That's largely because we have an outstanding amount of stock of Sky Hubs within our warehouse, which have an older firmware version, which is not MAP-T capable yet. So we let them connect as dual stack so that they can download the firmware updates and upgrade, and then they'll reconnect as MAP-T. Once all of that stock is remaining, that's when we'll start getting into the sunsetting of dual stack and disabling the DHCP-v4 servers. The majority of the customers running MAP-T are sharing an IPv4 address. So over 95% of them we see as sharing a v4 address with 15 other customers, but we still retain what we call an opt-out profile. Now, this opt-out profile is it's still delivering v4 over the top of v6 using MAP-T, but it doesn't overload the v4 address. That single customer gets the entire use of that entire v4 address. So v4 addresses, you still need them. It's going to be a long while until we can actually have true IPv6 only. So without getting into any of the religious debates or arguments around what IPv6 only actually means, we do have v4. We started with 0. It was a greenfield network. So once you create an LIR within the RIPE NCC region, The policy was, at the time, you received a /22 of v4. This was not going to be enough for even our infrastructure numbering, let alone subscribers. So we ended up borrowing a chunk of IPv4 from Sky UK. We decided to use that chunk of borrowed IPv4 from the UK to number our dual stack initial deployment. That way we can keep the remaining /13 that we bought from the open market. We can keep that as a purely dedicated for MAPT, because what I'll talk about later on in the slides is that one of the complexities with MAPT is the numbering and addressing schemes you have to come up with. So it's very beneficial to keep a clear distinction between dual stack and MAPT when it came to v4 addressing. The reason why we dual stacked initially was purely just to de-risk the product launch. MAPT is still a very early and new technology, and there is obviously some risk behind being an early adopter for that. But everything went swimmingly. So why did we choose MAPT? There are several other IPv4 as a service technologies, as well as you could just carry on going dual stack.
Richard, I have just a question, but this is not a technical question. So you say that it's so as it's a Sky, it's a greenfield network, it's a new network. What's the reason behind the choice to deploy an IPv6 greenfield network? And so in the IPv4 as a future delivered by MAPT, what's the reason and economical or technical reason behind this choice? That because I was not this guy.
So to deliver
yes,
v6?
v6, yes. What is the starting point that moved us to deliver the IPv6?
So it actually sort of stemmed from probably from the UK side of things. We quite a few years ago we went down an IPv4 extending, or there's a big program around the future of IP address usage in Sky UK at the time. We evaluated carrier grade NAT, we evaluated v6 and all the things in between. We knew we had to do IPv6, and we knew that there were real world negative impacts to customers by doing carrier grade NAT or NAT 444 at the time. So to de-risk, I guess, to mitigate a lot of the risk that we knew, the negative impacts of customer experience with CGN, we decided we needed to do v6. So that way, you know, for all those sorts of things like port forwarding, peer-to-peer gaming, all that sort of stuff, we wanted to make sure that v6 was an alternative to bypass carrier grade NAT and all that sort of stuff. So that was probably the reason why we decided to deploy v6 quite a few years ago now in the UK. And that sort of carried across into this network. Carried across the idea of going v6, but also because it was a greenfield network, we didn't have any v4. And I mentioned we did go to the open market and bought some v4/13, but that's not enough for our subscriber forecast. So unless we wanted to keep going back to the open market and buying additional v4, we had to do some form of address sharing. Does that answer the question? Sorry, Giovanni?
No, thanks, Richard. Okay.
Cool, apologies, I seem to have got some animation stuck in here. So yeah, as I said, we were evaluating the various IPv4 as a service technologies. MAPT is just one of them. There are others. There's an internet draft now. I think it's in v6 Ops working group's last call before it goes to the RFC editors. That has a good I should have had a link here, sorry, that has a good overview of the various v4 as a service technologies that you can potentially weigh up. And they each have their own pros and cons, and just because we decided MAP-T was best suited for us, it may not be best suited for your network. So some of the reasons why we considered it as a good technology and favored was so v6 access only layer, that's pretty obvious. If it can be v6 only and you don't have to run additional v4 infrastructure, then that's reduced operational overhead. So that was achievable for us in Sky Italia because it was a greenfield network. That's probably not going to be as achievable for everybody, especially in brownfield deployments where you've got to have a lot of legacy customers remaining on v4 infrastructure. As mentioned earlier, we needed to do IPv4 address sharing, but we also wanted the ability to have this one-to-one type technology to give customers a single v4 address, because there are negative customer impacts of sharing v4 addresses. We're aware of that, and we didn't want to be stuck having to do that. It's translation compared to encapsulation, so there's fewer bytes of overhead. It's not zero because a v6 header is larger than a v4 header, but it also leaves the layer 4 header exposed, so you can do 5-tuple hashing. The biggest benefit for us is that it's stateless, so that it means you can have more scalable hardware and hopefully more cost efficient. It's not without its downsides. Again, I mentioned earlier that the IP pool management becomes a lot more complicated. You're intrinsically tying the v4 usage now with your v6 usage. And at the time when we went to RFP, none of the vendors could actually provide us a real-world reference customer, so that didn't fill us with confidence. Bit of an overview of the topology of how MAP-T looks like in Italy. We have the dual stack LAN on the left-hand side. You have the stateful NAT44, which includes port translation between the private RFC 1918 and the public v4 address. And if you're sharing the v4 address, the layer 4 port will be translated as well into a fixed set of ports that a customer is allowed to use. It then passes through a stateless NAT64 translation and pops out within the network as v6. Across whatever access and metro networks you may have, then comes across to the MAP border relay. Our MAP border relay happens to coexist or is co-located with the BNG, or the broadband network gateway function, on the same device itself. So that does another stateless NAT64 translation and spits out v4 towards the v4 internet. As mentioned before, MAP comes in two flavors. There's the translation, encapsulation, sorry, which just whacks a v6 header on top of the v4 packet, or you can translate. The problem with translation is that there are attributes in a v4 header that don't exist in a v6 header, so that translation itself to v6 and then back again is not a lossless translation, so you will lose some of those attributes. You're going to want to try and build your network to avoid fragmenting these translated packets, because both of these technologies will add additional overhead, as you can see. Neither is zero, so you'll need to dimension your access and metro networks to handle that additional payload. It is harder for devices, the border relays in particular, to translate IPv6 fragments. So you want to avoid it where possible. We've also got a variety of wholesale access networks providers in our network. So not all of them will have the same size or same same backhaul networks that offer to support the same frame sizes. Our design involves actually increasing the interface MTU on our WAN side. The idea is, again, as mentioned, to avoid the fragmentation within the network, but it's not quite as simple as just increasing the MTU to 1520. There's a lot of other sort of quirks involved with that, not least of which is PMTUD issues with any self-generated traffic from that CPE itself. Quick diagram or overview of how the translation looks. As mentioned before, there's the stateful NAT44 in the CPE. This is pretty traditional, as you understand NAT44, and then you've got the stateless translations from both the CPE and the border relay. We have time, so we'll go and skip through a few of these. This is sort of the /13 that we bought from the open market. This is roughly how we carved things up. As mentioned, it's complicated with designing how you're going to use these v4 addresses now with MAPT. So we had to be relatively, we had to think about this to satisfy all of our requirements, both now and in the near future. And you're tying them to your v6 addresses. So the number of the sizing of your v4 prefixes has to match up with the v6, the DHCP v6 pools that you're going to be creating. So you can see here I've got the sharing ratio of 16:1 and how we've kind of chunked up the various prefixes. Hopefully the slides will be available so you can go back through these if you want to look at them in the future. So the pool management, comparing it to what we do in the UK. The UK, as said, has been dual stack for quite a while. We had automation in place to dynamically manage the DHCP v4 pools as tightly as possible, because it was very important to squeeze as much efficiency out of those v4 pools as we could, the prefixes. But the DHCP v6 prefixes or pools that we used in the UK, we just over provisioned them, and we did that manually. So we had we dimensioned the DHCP v6 pools to cover an entire BNG worth of subscribers. So we knew we were never going to run out of v6 prefixes in our UK dual stack deployment. In Italy, however, because now the size of the v6 prefix is mapped to the v4 usage, we have to be a lot more careful around how we dimension our DHCP v6 pools. If we were to do the same thing as in the UK and just over provision our DHCP v6 pools, we'd be wasting v4 addresses. So now we need to build a new platform to automate the management of v6 as well as MAPT rules. v4 address sharing, as mentioned earlier on, we have about 95% of customers that are sharing 16:1, but those other ones that are on the 1-to-1 profile can do things like port forwarding, enabling v4 DMZ, but it can also allow for forwarding of non-layer 4 or non-port-based layer 4 protocols such as GRE. For those using the SkyHub itself, we've built in some automation that allows the SkyHub tells the network when a customer is enabling these features like DMZ and port forwarding, and that allows us to, sorry, there's some noise on the line. Yeah, so that allows us to automate the opt-out process from the 16:1 sharing ratio to the 1-to-1 ratio, and then also allows us to opt them back in if they disable the DMZ, for example, in the future. Sorry, Giovanni, are you? Could you go on mute? I think
I am on mute. I don't know.
Someone else.
Yes, Please, so guys, so please take mute the bot. Okay, it seems the noise disappeared. Okay, go ahead.
Thank you. So yeah, as mentioned, it's we're predominantly focused on our SkyHub as the customer premise equipment that we give out to all of our customers. This is based on the open source RDKB stack using a Broadcom system on a chip. We initially trialed this, or did a proof of concept with this CERNET implementation of MapT, but that was very much a proof of concept. It was what Broadcom included within their SDK, but it had some limitations. So we've now since migrated to Andrew Yurchenko's NAT46 kernel module, which is the same implementation that's used in OpenWRT. So it's again, it's on GitHub. You can view it, and if we needed to fix it, we can. One of the benefits for that. The version we have in our SkyHub is slightly modified by Broadcom in order to support their hardware acceleration of their SoC, just so that we can get proper 1 gigabits per second through this small CPE. I think I mentioned, or maybe glossed over in the cons slide earlier on, is that it is a very new technology, so there are few CPEs available on the market. OpenWRT, as mentioned, has very good support, but there's not that many hardware devices out there you can go to a shop and buy that has OpenWRT out of the box. I would like to make a call out or a shout out to Kinetic. They have recently announced an alpha release of their CPE firmware, which has enabled MapT. It's still very early days, but they've been very proactive with reaching out to us and working with us to build their support. So big ups to them. Link down the bottom if you would like to go and check that out. Within the CPEs, we're using traditional near filter IP tables to do the source net translation and also the port translation if it's a v4 sharing profile. One of the things we did discover is that I haven't really spoken to the technical details around the MapT translation algorithms, but depending on how you build the profiles, you chunk up the layer 4 port ranges into blocks, and you allocate a single customer multiple non-contiguous blocks. So in this example, you can see we have ports 1152 to 1215, or 1152 to 1215, but then the next block is a completely different range. So one of the problems that we observed with NetFilter and its usual SNAT target is that it doesn't allow these ports to be used and then for the rules to fall through to the subsequent rules. So without any modifications, you'll see the top rules being matched, and then all of those source ports will be exhausted, and the below rules will never be hit. So there's a NetFilter module called conlimit or connection limit, which allows you to say, in this example in the screenshot, up to 63 connection or flows will match this rule and match the source NAT for these port ranges. But then once that limit is hit, that rule will no longer be matched and it will fall through to the subsequent rules. That way you can keep using additional non-contiguous port blocks. There was another limitation with that conlimit match, and that it was missing the destination port in the hashing. So in theory, you can reuse source ports over and over again if the destination address or destination port are different. So that didn't really work with the current conlimit module. So Broadcom patched that for us, and that hasn't. I think they were going to try and upstream it with NetFilter, but I don't believe it's been upstreamed yet. It's not a blocker for any implementation out there that wants to do this. It just means you don't get quite as efficient source port usage as you may get otherwise with it. There's quite a few other complexities you have to think about with MAP-T, especially around regulatory compliance. There are some jurisdictions which require you to provide full 5-tuple based logging with any v4 translation technology that you use. Because this is stateless, we don't have any of those logs of all of the flows. So thankfully, Italy didn't have those requirements, but other jurisdictions do. In Italy, they did have a requirement, however, that we can only share v4 address up to 16 ways, which is why we've chosen that for our profiles. For mobile, I do believe they allow you to go a bit higher. If you recall, in the topology diagram, I showed the map border relay function was co-located on our BNG function. That has some additional benefits in this regulatory space than lawful intercept. If you were to decouple the border relay function from the BNG and put it elsewhere in your network, then these types of requirements may get a little bit more challenging, and you'll have to probably come up with some creative ideas to satisfy them. We did still have to, even though the map border relay function was done on our BNGs, we still had to create some sort of customization around radius accounting feeds. So we are synthesizing MAP-T information within our radius accounting data, session data, so that we can keep track of the v4 information in the v6 accounting session data. There is an RFC now. It's again relatively new one, which standardizes this approach of embedding, they call it soft wires, but MAP-T information into radius accounting data. Our BNG vendor is promised to support that in the near future. Quite a few other things here. So CDN steering. As mentioned, our border relay is co-located with our BNG, but if you were to decouple that and move the border relay function around your network, you have to be aware that you may be tromboning or funneling v4 packet flows to get back through the border relay in order to come back to the BNG and where your subscribers terminate. So if, for example, in our UK network, we have a lot of CDN content delivery networks distributed quite close to the customer further down towards the BNGs. If we were to have border relay centralized, then we would be forcing content to either trombone or be served from centralized CDN. A lot of CDNs also make use of eDNS0 client subnet, which embeds the source IP address into a DNS query before it hits the recursive DNS, well, when it hits the authoritative DNS platform. So they can make CDN steering decisions based on where that DNS query came from. So for our topology on our network in Italy, that is all v6. So it's much more simple to build a topology map with v6 and smart CDN steering decisions without having to worry about lots of arbitrary IPv4 prefixes and prefix sizes floating all over the place. Yep, mentioned about v4 topology being different to the v6 topology. What I haven't mentioned, however, is that because MAP-T is stateless, you can anycast both the v4 prefixes as well as the v6 prefixes. So you could distribute lots of MAP-T border relays around your network and just allow packets to come in and out of whichever is the closest border relay to that device, because there's no need to worry about state tracking every single individual flow. There is another thing I'd like to call out here. We haven't made use of this in Italy, but it's a cool feature that of MAP-T, which we are looking to deploy elsewhere, and that is border relay bypass. This is a name I've given to this sort of trickery or hackery where you can, because it's stateless, then you don't have to go through a border relay translation to get back to v4. So if you can predict the v6 address that will be generated by this translation, you can embed that v6 address. We can embed the v4 address into the v6 address and put it onto a CDN server. So this would allow you to serve v4 only clients from v6 only CDNs. This could help with any of those sort of crazy tromboning or centralized CDN steering issues I mentioned earlier on. There's probably a lot of people maybe cringing at doing this. This is from a network layer perspective. So from IP routing, this is pretty simple. The routers will do a longest prefix match on this v6 address, and it'll get directed straight to the local CDN rather than going to the larger /64 prefix of the border relay. From an IP routing perspective, that's simple. From an application layer perspective, I'm sure there are probably some CDN people, hopefully on the call, that will be cringing, because the applications can do different things. Applications may use source IPs for authentication. They could potentially tokenize CDN content and URLs using source IP addresses and all sorts of horribleness, which will complicate it. But from an IP networking perspective, I think this is quite a neat little thing that I would like to play with in the future. So I have another slide. This has not been entirely smooth sailing. It's been pretty good. I don't think we've had any major issues or insurmountable issues that has required us to roll back or anything. So that's been absolutely fantastic. But we do have a few little things we would like to finish tidying up. Aesthetically, there is a bug we know on our border relay, which is preventing v4 TTL exceeded messages being translated into ICMP v6 time exceeded translation messages. Sorry, that sort of manifests itself as broken IPv4 trace routes. Hopefully, we'll get that fixed in the not too distant future. Slightly less aesthetic and more performance impacting is we have noticed there were speed issues when trying to translate full 1500 byte IPv4 packets. So in the meantime, until we get to the bottom of that, we're using TCP MSS clamping to artificially lower the resulting packet size to keep it within the limit so that you can still get full 1 gigabits per second throughput across the network. Another problem that we have is on our DHCP v6 server. I've been unable to convince our vendor of the problems, but we do have some workarounds we're going to be rolling out soon. This manifests itself in the way that non-MAP-T capable CPE devices cannot obtain a v6 only prefix or lease. So they should be able to connect with v6 only, and because we have v6 DNS recursive DNS platform, they should be able to browse the v6 internet. This is very important for devices like OpenWRT, which they don't have the MAP-T module installed by default. So you need to get on the internet with v6 only, and thankfully the OpenWRT package repositories are v6 capable. And so they can connect to the v6 only, download the MapT package, install it, and then reconnect with MapT. So that's why I'm calling this one out as a pretty important issue that we need to resolve shortly, and we will. And that's it. That's the last of my slides. Happy to take questions. I'm not sure what time we have. I wasn't tracking. Sorry, Giovanni.
Yes, I think that we are on track. But if anyone has some question, we can go. I have a question, Richard, just to understand about the way in what the authorities can get the IP behind the translation.
Okay.
If I've understood, it's radius accounting or not? Or
how exactly is probably can't go into too much detail, but yeah, there's radius accounting. So like any broadband network, we would, well, any traditional fixed line broadband network, we have radius accounting session data that is generated by the BNG. That is one of the functions, for those not familiar with a broadband network, that's one of the main functions of a BNG is to authenticate, identify customers, and generate that accounting session data. So yeah, that's one of the reasons why we are synthesizing the MapT information or attributes into that radius accounting session data. Yeah.
Yes, I think it's a good solution because I remember that I faced a lot of problem with the log, especially for the authorities, because we have to log everything. This so was a big issue also for the logging server where you can have to store the logging, and it's
you mean for like other v4 sharing type methods,
yes,
stateful ones? Yeah,
yes,
exactly.
Yes, there was also a problem. So how we can collect log if you use a traditional architecture with CGNAT. There was a lot of challenges that we faced in another ISP where in what we have to collect log, where we have to store the log, and the way we have to store the log.
Yeah,
yeah.
And I've seen similar. Well, I've seen other deployments of traditional carrier grade NAT where when we played around with it years ago, we were aware of that data storage requirement, and we said, okay, here's a fixed number of layer 4 ports a customer can get, and that's what you can get. Other CGN deployments are a bit more dynamic. They'll give you ports whenever you require it. So if you're being very dynamic and allocating them as required or just in time, that can be good from a IPv4 address sharing efficiency use, because maybe you could fit 100 or 200 customers behind a single address because they only use the ports they need. But it provides more logging data because you got to log every single flow.
Yes, and also the problem if you lose some log, and also you have to also arrange a mechanism to correlate different log.
Yep.
So I think it's a good solution also for the logging. So to log all the information required from authorities.
Yep. Well, it means we don't have to log. It means that
yes, exactly. Yes, we don't have to log. Yes.
Or have to log additional things. It just comes for free basically with our accounting session data. Yeah.
Okay.
There's a question in the chat. If you don't mind me reading it out. Did you, Phil? Do you want to call it out, or should I read it out?
Yes. Okay. You're able to read?
Yeah. So why did you decide to go with non-contiguous port ranges for 1 to 16 customers instead of one bigger range? Cool. Yeah, great question. It wasn't really, so I guess there are some potential concerns around privacy if you wanted to, if you had a single contiguous block, then it's quite easy to, I guess, identify who has what range. That's not our main concern. It's largely a side effect of the map rules and how they're created. So I took out all my other slides of how MapT kind of technically works, but in the basic mapping rule, there's a variable called the PSID, or port set ID. there's also a PCID offset. Now that offset defines how many bits that PCID value is offset from the start of the block. The algorithm that tells you what ports you're allowed to use, that offset determines that. So I'm kind of working around it a little bit. The main reason is that offset is 6 bits, and 6 bits is so that we can avoid ports 0 through 1024. So those privileged ports, which you normally get TCP 80 for web servers or TCP 22 for SSH, we don't want those to be assigned to subscribers to use for source ports, because I don't agree with it, but there are some firewall administrators out there who decide to block source packets coming from TCP 22, even though it's legitimate traffic destined for HTTP or something. So yeah, because there's some problems with that, we avoided those ports. As a side effect of avoiding those ports, it kind of chunks up the port ranges into non-contiguous blocks. Sorry, it was a roundabout sort of answer, but hopefully it answered the question. There's another one there. Thanks to Represso. Thank you very much. Just wondering if ISPs having only fixed operations should consider MAP-T rather than 464 XLAT, according to your experience, but those with mobile operations may still use 464 XLAT to integrate operations knowledge. Yeah, absolutely. So again, I say there are a variety of v4 as a service technologies you can use. 464 XLAT is definitely one of them, and that has definitely seen a much more popular uptake within the mobile space. It's one of the very publicly visible and vocal proponents of 464 XLAT, Geordie. He's also campaigning for it to be used within a fixed line broadband network itself. It's just you'd need the 464 XLAT or CLAT function to be done on the CPE, whereas at the moment that CLAT function is done on the mobile handsets quite a lot. And then also you need DNS 6.4 synthesizing and some other stuff. So yeah, you make the decision on what works best for your network. If you have a mobile network already, then and you're already doing 464 XLAT in the mobile network, then perhaps doing 464 XLAT in your fixed line broadband network would be the way to go. Similarly, there's another protocol called lightweight 4/6 that's more akin to DS Lite. So if you were using the older, more stateful, less scalable DS Lite as a V6 transition technology, if you were to upgrade, you might just go straight to lightweight 4/6 because that's the natural evolution from a technology and an architecture you've already used. Cool. No problem.
Okay. Okay. Thank you, Richard. Thanks for this good explanation and the state of a MAP-T in Sky Italy. Thank you so much. Okay, I can go ahead. So there was a change in the agenda. Now is going to speech Giuseppe, and then so George. Giuseppe, are you ready to start?
Yes, it's okay.
Thank you.
Can you hear me?
Thank you. Yes, I can. Thank you.
Okay, good, good. Let me share. Can you see? Can you see my screen?
Yes, I can.
Yes,
I can.
Giuseppe.
Okay, okay.
You're there.
Let me start, yeah. Okay. Yeah, this is a quick update about what are the hot topics in IETF, in particular with the focus on the last IETF that was in November last year. And I have selected all the hot topics for IPv6 because we are in the Italian IPv6 Council. So let's focus on IPv6. So yeah, first of all, I want to highlight that there is a document that is about the IPv6 deployment. It aims to analyze the current IPv6 deployment status. In particular, the scope is to provide the latest IPv6 deployment progress among network operators, enterprises, cloud service providers, industry. And the scope is not only to highlight the status, but also to analyze the common challenge and the pain points of the IPv6 deployment. So that's why the investigation is also involves operational, performance, and security aspects. The key findings of this work is about maybe you are all experts on IPv6, so of course that IPv4 exhaustion is one of the main incentives for IPv6, but this is just one initial consideration. In the end, also in this document, it is analyzed that the end-to-end IPv6 service chain is now ready because except for, let's say, the network part, the operators and enterprise that are relatively in late, but we can say that for terminals and content, the IPv6 readiness is quite advanced. Also, IPv6 is growing faster, is growing very faster than IPv4, even if we have to differentiate between countries and operators. There are countries that are in a more advanced situation, while other operators are late. And also, as Richard also highlighted in his presentation, it's important to separate between IPv6 only service delivery, so the overlay, and the IPv6 only network deployment that is the underlay. So we have to consider also this aspect. Okay, yeah, this document has been adopted in IETF, so there are also several operators that are actively contributing in this draft. So it will be great if you can have a look and give inputs. I am also one of the co-authors of this document, so you can contact me or one of the other authors. It will be great. Yeah, another important topic that I want to mention is the use of hop-by-hop options. You all know that one of the main, let's say, property characteristic of IPv6 in comparison with IPv4 is the extensibility of the protocol, and this can be done through extension header. So there are several proposals in IETF that aims to use hop-by-hop options header to make advanced services, because through hop-by-hop header, you can signal to routers to give a special treatment to packets, and this can be used to facilitate, to introduce new services. But there are operational limitations on this, because many routers may discard packet with hop-by-hop option due to several issues. For example, the inability to process at wide speed. The hop-by-hop options are also sent to slow paths in some cases, and this, of course, will degrade the router performance. And also, you can imagine that if there are several proposals that aims to use hop-by-hop option, in the end, a packet could contain multiple hop-by-hop options, and this could also make the problem worse. So what is the solution? So there are two drafts that have been adopted in IETF, and there are a lot of discussion around this topic. The solution is to modify the op-by-op processing to make the op-by-op option more practical for future uses. So, and in particular, there are 2 points under discussion. So if an op-by-op option header can be expected by a router outside a limited domain, and if there are general limits that can be done, for example, for the op-by-op option. For example, if we have to accept only one op-by-op option or more than one, if there is some priority and something like that. So this is just to say to you that there is a lot of discussion in IETF about how to modify the processing of op-by-op options to facilitate new services. I also invite you to have a look to this document if you are interested. The first idea is to focus on limited domain use cases, because if you are in a limited domain that can be, for example, a network operator environment, you can say, okay, in this limited domain, I can set this rule for the op-by-op option, while it is difficult to set rules for the whole internet, right? So if we are going to use op-by-op option for advanced service in a limited domain, maybe there is more space to set rules than the whole internet. An example is for example, the alternate marking method. So there are a bunch of new methodologies that aims to make advanced performance measurement technique, also by leveraging the extensibility of IPv6 headers and IPv6 protocol. So this method consists of batching packets by switching the value of flags in order to measure loss and delay. This can be used together with other methodology like in situ OM. Maybe you heard about this in situ OM methodology. And one of the opportunity that IPv6 gives is the possibility to have these op-by-op options and to encapsulate in these op-by-op options new flags to make advanced telemetry. In IPv4, this was not possible, right? Because you cannot, there is a possibility to define option, but it is never used. So we can do that because IPv6 allow us to extend the protocol. So there is just a little fixed space, 32-bit in the IPv6 header that can be added in order to define this new option. It can be, this new methodology allow to measure, it can be used together with destination option, and it allows to do measurement only by the node in destination address. Otherwise, it can be used as a op-by-op options. So every router on the path can do the measurement. Otherwise, the destination option preceding a routing header allow that every destination node in the route list, for example, if we are using segment routing v6, every node that is an ID can do the measurement, or it can be also used as an SRH TRV. So every node that is an identity in the SR path can do the measurement. So this will be published soon by 6-man working group. And this is one of the examples why op-by-op is a hot topic, because there are several proposals like this to leverage the op-by-op options to make advanced functionalities. And of course, IETF is working to make this op-by-op processing more practical in a real implementation. Another important we all know that one of the, let's say, the new characteristic of IPv6 in comparison with IPv4 is the neighbor discovery protocol that is quite new in comparison with IPv4. For this reason, since it's quite new, there are a lot of challenges because with IPv4, engineers and all the, let's say, the experts gained during the years a lot of experience to improve, to overcome solutions in terms of security, in terms of deployment for IPv4. But of course, for IPv6 on neighbor discovery, there is less experience. For this reason, there are a couple of drafts that are investigating how to make the deployment of neighbor discovery and to make this protocol more robust in a real deployment. For example, this document is quite new. It's a new topic in the last IETF, and it aims to analyze the neighbor discovery protocol behavior that in some cases may lead to some network prefixes invalidity and host outage. For example, in case of non-graceful CPE reload, in case you have an abrupt hardware replacement or an abrupt prefix change after a router configuration, or a VLAN change, and so on. So all these kind of events may cause several problems and several issues with neighbor discovery, in particular with neighbor prefix invalidity. The solution that this document is going to address is to give some guidelines, to give some let's say deployment suggestion on how to make the neighbor discovery prefix robust. For example, there are several solutions. So prefer the default router that advertise prefix for source address, deprecate prefix index information if the prefix source is lost. So there are several solutions on how to use the neighbor discovery prefix and have it deployed in a more robust way. So it will be great if you have some experience on this topic to let us know if you have some input, and if you are also interested in this work, you are welcome to join, of course. A similar approach on neighbor discovery is about the neighbor discovery deployment guidelines. This is a more general document because if you look at IETF documents, there are several RFCs that are related to neighbor discovery issues and solutions. This document aims to let's say to have a better guide for an engineer that need to know how the neighbor discovery protocol can be deployed in the best way. In particular, this document summarizes the well-known neighbor discovery issues and solutions, and just put all of these in a single document. And I think it is very interesting for this point of view, because you have just one-stop document, one-stop reference, so you can reference to this document and to understand what are the best guidelines for neighbor discovery protocol deployment. So also in this case, we welcome your comments, your contributions, and I also invite you to have a look, because it's a very good reference document in the future for those people who are interested to deploy neighbor discovery. Yeah, now we are jumping to another topic, because I have first described the activity for the IPv6 working group in IETF. I have just selected the topics that in my point of view, and also in my team, we are working on. So it's something that we consider relevant for IPv6 deployment. Now we are moving to another hot topic. So I assume that we are all familiar with the SRv6, and there is a new trend in IETF, a new proposal to work on the compressed SRv6 seed list. The rationale in this case is that with SRv6, you are going to define a new packet header, a new segment routing header, and the packet header, since a segment is an IPv6 address, 128 bit for each segment is too much, and the length of the packet header may also exceed the patent use, so it can imply some issues in deployment. That's why there are several proposals in the industry and in IETF in particular on how to make compression of the segment ID list. I have included here two links to documents that are going to analyze the compressed seed list requirements and analysis. So there is a design team that is working on this. The first scope is to define the requirements for a compression a seed list compression solution, then analyze the existing solution. There are 4 different solutions in IETF. One is called compressed seed. I'm going to shortly describe what they aim to do. For example, the first one is about the compressed seed encoding that can be done, for example, when you have a sequence of seed that have a common locator block. And in this case, you can avoid the repetition of the locator block of the segment ID. And you also, in this way, you can use a compressed seed because you can avoid the repetition of the common part, and you can only define the variable part, right? So this is also flexible, so the combination of compressed and uncompressed sequences may be used. And this is for this solution. Another solution, it's quite different. So the first solution is going to reuse the same SRH. So the only difference is that 2 new flavors are introduced in order to manage this compressed seed. The second one is called compact routing headers, and it aims to define 2 totally new routing header types. So in the first case, we are going to reuse the existing segment routing headers. With the second solution, we need to define 2 new routing headers. And we also need a mapping between a label and the IPv6 address. So 2 new routing headers called SRH16 and SRH32 because they want to use label of 16-bit and 32-bit respectively. Another solution is about the SRv6 variable length seed that proposed to define one part that is the prefix that is dedicated and fixed, and another part that is variable. And then the last one is about that aims to extend the SRH to carry MPLS label for SRv6 as well. So this is more about a mapping of the MPLS label and to be applied in the SRH. And the new flag, they want to define a new flag to indicate which type of seed are encoded in the SRH. So the design team want to analyze all these 4 different solutions and to reach consensus among the design team members. Design team members are involving in particular operators and vendors. And this is a really hot topic in segment routing area in IETF. Yeah, in this slide, I have put the results of the analysis of 4 competitive proposals. The requirement and analysis document have been completed. It is not yet an RFC, but it has been adopted in IETF, and they have to fix something. There is a consensus that the first solution that I have described, the so-called compressed seed, is let's say a join between Cisco and Huawei, has been considered as the best candidate. Because in the beginning, Cisco and Huawei had 2 different solutions, but they in the end combined the solution with this compressed seed. And if you go in the table, there are different parameters that they consider, that the design team consider in the analysis. And in the end, the compressed seed, in particular in terms of forwarding efficiency, SRv6 based, is the best, because the compressed seed does not modify the current SRv6 and SRH definition. So it's more, let's say, backward compatible with SRH. But the compressed SRv6 seed progress also had some issues to solve. As I said, there is some discussion ongoing in IETF on what is the best solution for compression. But on the other hand, you know that in IETF there are different working groups. The IPv6 guys are also investigating how the compression is going to modify the original IPv6 specification of RFC 8200. That's why there is some discussion here about the lack of clarity about seed and the requirement for IPv6. So, for example, we are expecting a new document to cover some areas like how do seed deviate from classing IPv6 addressing architecture? Does neighbor discovery apply to seed? So how do segment routing aware and segment routing unaware nodes treat seed? So there are some pending points that need to be clarified, because if you are going to make a standard, you have to answer and you have to be compatible with the original IPv6 specification, with at least with the RFC 8200. And of course, there is an high expectation in segment routing working group, but there are some pending points to address in 6 months. So let's say that we are in a good stage now, because it seems that there is an agreement about what is the best solution for compression, but there is some work to do, still some work to do to solve some issues. Yeah, I think this is my last slide. Yeah, I know that the presentation is too technical, but about IETF, but if you have questions, of course.
Okay, thanks, Giuseppe. Any question?
Giuseppe, I was about to type, but probably I make it more easy for me to read out. So, is SRv6 usable without compression? So, or is there any way already available to have this compression done? Let's say,
yeah, of
while
course,
standard is progressing.
Of course, SRv6. Yeah, maybe here I didn't consider the status of SRv6 alone, but just focused on compression. Let's say the SRv6 has already been standardized, so there are RFC already published for SRv6 programming, for SRH definition. So the base SRv6 is already been defined and stable, and most of the vendors already implemented it. But here, this is an evolution, because since one of the challenge of SRv6 is about the packet header length, that is one of the concern of most of the operators. That's why the industry is working on this compression. The solution about the compression, since we want a multi-vendor solution, maybe there is not yet a unique solution, but the design team is working in this direction. So it's working to select only one of these solutions in order to allow all vendors to implement one of these solutions. As I said, the best candidate looks like this compressed seed, but this is still under definition. But of course, the base SRv6 can be used. The compression activity is only related to solve the main concern of SRv6, that is the packet header length.
Thank you. Thanks, Giuseppe.
Yeah, well.
Okay, interesting. I don't know, because we have just 10 minutes.